Today we're going to introduce the idea of a scatter plot, which you've done before previously, but then we're also going to figure out how to write an equation for scatter plots and something called a correlation coefficient. This is all done in the calculator, so you need a calculator. You need to be following along with me as I'm speaking, and then if you're seeing an issue with your calculator, you need to be asking questions so you can fix it. Okay? So, first let's talk about a scatter plot. Let's start with what we already know. So see here how I have dots, and these dots are making a perfectly straight line, right? This is perfectly linear. A perfectly linear relationship. Remember, this is a positive slope because it's going up, right? And we've done that before. It makes a straight line, it's linear. It's going up, it's positive. These dots, they make a straight line, a perfectly straight line, so that's also linear. But they're going down, so this is a negative slope. Okay, so this is what we already know. Okay? Now, with a scatter plot means that there are dots, and they're kind of hard to see, but we have dots here, right? But are these going to make a perfectly straight line? Some of you will say, well, you could draw a line like that. Yes, you could connect the dots, but that's not what I want you to do. I cannot draw one perfectly straight line. So it's not linear, it's a scatter plot, but it still is what we call a positive correlation. Or you also might have heard trend. Or trend. Positive correlation or trend, which means it's going up. Whatever it is, those dots are going up there. Okay? Now this next one, it's not a perfectly straight line. It's not linear, but it is going down. So this is a negative trend. Or negative correlation. Okay? And then you have them where they're going all over. This is not a straight line for sure. I can't tell if it's going up or down. They're kind of everywhere. So this is no correlation. Or no trend. And that should be somewhat familiar from last year. Okay, positive, negative, or no trend. Okay, so it's either perfectly linear, or it's going in a positive direction, a negative direction, or it's going in no direction at all. Okay. However, what we can do is we can find something called a line of best fit. Now, a line of best fit is a line that best goes through the points. And we're going to calculate that on a calculator. However, what that would look like, I'll use blue here, like a line of best fit here would be something like this. Okay, it doesn't hit all the points for sure, but it about goes in the points, or in the direction of the points. And this one would be something like this. Because it's about going in the direction of the points. So we're going to calculate the equation of that line with the calculator. Here's what we have to do first, though. We have to turn something called our diagnostic on. So let me go up here for a second. Turn your diagnostic on. Here are your steps. So we have our calculator here. Move this over here a little bit here. Okay, we have our calculator. What we're going to do, and I'll hit it in a second. We're going to hit second and then 0, which is the catalog. Second, 0. So, I'm going to write that down. Second, and then 0, which is the catalog. Okay? That's what I did. And this part's annoying, but you're going to go all the way down to diagnostic on. Which you can do faster in your calculator. My calculator takes forever. We only have to do this once, though, at the very beginning. So, all the way down until we see diagnostic. Let's see. Keep going. Alright, we have diagnostics off, and if you go down one, that's diagnostic on. And then you hit enter until you see done. Okay, so then your steps would be down to diagnostic on. And then you hit enter. You're probably going to have to hit enter it twice until you see the words done. That turns your diagnostic on, which you're going to need in a little bit, okay? So, till it says done there. So that's how we turn the diagnostic on, which yet again, you probably have no idea what that means, but that's okay. Alright, so, we have this set of points right here. We have these sets of points. You could plot them on a graph and look at them, but what I want to do is I want to find out what equation best goes through those points. What's the line of best fit? And we're going to round to the hundredths. So here's what you're going to do in your calculator, okay? You can clear this out if you want to. We're going to look at my screen and then look at your stuff. We're going to hit the button right here that says Stat, So stat, and then we're going to hit enter for edit. Stat edit, and it brings up this table. So we're right here, so we're going to write stat edit. Okay, stat and edit, that's what we hit. Okay, and I'm going to move this over a little bit. Here's what we are going to do. Don't worry about L3. I don't care about L3. L1 is like the X's. L2 is like the Y's. So you're just going to type these in. This says -2, -6. So -2, enter, and then you go over to the right and you can hit -6. Enter. Go back to the left. This is 621. So 621. Or if you want to, you can type the whole table in at once. Like I can do 8 and then 10. So 8, 10, and then go over. 8 matches up with 8. 8, we hit enter, and then 16, enter. So all I did was I typed in the X's go in L1 and the Y's go in L2. And if I look, it matches. So on your paper, that's the first thing. Second thing, X's are in L1, and the Y's are in L2. Okay? We good? Alright, so now what we're going to do is we have our table in there, and we're going to write an equation for it. Follow along with me, and then we'll write the steps. We're going to hit stat again, which is right here. Stat. And now instead of editing, we're going to go over here to calculate. So over to calculate. Alright, and then, so stat, calculate, and then we go down to what here says linear regression. Lin reg. Stat, calculate, lin reg. Follow along with me. You hit enter. Has all this beautiful stuff. We go down to calculate, and we hit enter one more time. And it gives us all this gross stuff. I'll go over all that gross stuff in a second. So let's write that stuff down though. So the third thing you do is you go to stat, then you go calculate, and then number 4, which is lin reg, and then all the way down to calculate. Okay? So just to show you real quick again, we hit stat, over to calculate. You can go down to 4 or just press number 4, all the way down to calculate, and then we just hit enter, and it gives us that. Okay, so here's what you need to know out of this. So see how it says y equals ax plus b? The a value, that is just your slope. And see here how it says round to the hundredths? So hundredths means 2 decimal places. So 1.7, now this 7 is here. Is that 7 going to make it go up or stay the same? It's going to make it go up, right? So 1.78. So y equals 1.78x. So look at your calculator. I rounded that, and that number goes, the a, I know it says a, but it's just the slope. Okay, plus b. Well, b is -0.0, and then this 2, is that 4 going to make it round up or stay the same? Stays the same, right? I'm not going to write plus negative, so I'm going to put minus 0.02. And that's my equation. My slope is 1.78. My y-intercept is -0.02. That is the equation that best goes through those points. If I were to plot those points and then draw that equation, that's the best one. Now, correlation coefficient in your calculator is the r. Not r squared, r. So I don't care about r squared at all. I only want r, which is 0.79. So on your calculator, or sorry, it's 0.79307, but we're going to round to the hundredths. So that's 2 decimal places. That 3 makes it stay the same, so 0.79. You can put r equals here. Okay, and we're going to leave off this positive, negative, strong, weak for a second. Okay, so let's do example 2. So let's follow these steps again. I do not have to turn my diagnostic on again unless you clear the memory of your calculator. If you clear the memory of your calculator, you got to do it again. Okay, but if not, I'm just going to follow this. So in my calculator, I'm going to go to stat edit. So I just clear that out. Stat edit. And I have all this stuff in here. So to clear it out, here's what you do. And if you need to write this on your paper, please do so. You go to the top. You do not hit delete. Do not hit delete. If you hit delete, you need to get your teacher to fix it. Go to clear. Nothing's going to happen, but then go down. And then everything goes away. And then go up there. You hit clear. And then down. It all goes away. All right. So we're going to put this table in there. So the x's are 1, 2, 3, 5, 5. And the y's are all those. So I'm just going to type them in. So make sure they match. So I'm going to do 1, 2, 3, 5, 5. Those are all my x values. 1 matches up with 2. So I'm going to hit 2. 2 goes with 7. 3 goes with 4. So 4 goes there. 5 is 2 and 8. So 2 and 8. Make sure you match them up. Make sure they look good. Looks good to me. Okay. So if I go to my steps again, so stat edit, X is an L1, Y is an L2. We go back to stat, then calculate. So we hit stat again. We go over to calculate, and it's option 4, linear regression. You can hit number 4, or you can go down to number 4. And then all the way down to calculate. We hit enter. All right, so we are going to write this. So y equals this a, we're going to round 0.34. Does this 3 make it go up or stay the same? It stays the same. So 0.34x. So y equals 0.34x. And then my y-intercept is a positive 3.5. So plus 3.5. That's easy. My correlation coefficient, remember, that's whatever the r says, which we'll go over in a second what that means. I don't care about r squared. R is a positive 0.22. So r is a positive 0.22. Okay? So the line of best fit is just the stat edit stuff. This is a line that goes through those points as best as possible. The correlation coefficient, that's what we're going to talk about here real quick. Okay? So your correlation coefficient is always going to be between -1 and +1. Always. Okay? If it is exactly +1, that means it is linear. And it's positive. So remember at our first thing right here? Linear and it's positive. That means it makes a perfectly straight line. If it is exactly -1, that means it's also linear. And it's negative. So it means it's a perfect line. It's not a scatter plot. It makes a perfect equation. Okay? But as you can tell, these aren't positives and negatives because these aren't perfect equations, perfect lines. These are scatter plots. Okay? So, if the correlation coefficient is negative, okay, and every teacher is going to be different, I'm going to say, I'm going to put this at 0.7, and this over here is also at 0.7. I know it's not perfectly at 0.7, but just stay with me. If it's between -0.7, -1, this is a strong negative. And what we mean by that is it's a good prediction. The dots are pretty close together. And this would be a strong positive. Here's what I mean by that. So like this is a perfectly straight line, right? A strong positive might be it's going up, but those dots are pretty close together. Anything in between there is going to be weak. And if it's between here, like maybe it's -0.2, that'd be weak negative or weak positive. An example of weak positive means it's going up, but those dots are not close together. That's a pretty weak line. Okay? Same for negative. So if it's perfectly -1, it's a perfectly straight line. If it's a strong negative, it's not a perfectly straight line, but those dots are pretty close together. It's going down. If it's a weak negative, like here, then they're going down, but it's just all over the place. Okay? So, that's what that is. We're going to practice a little bit more on the back, but before we do that, let's go right here real quick. So here, is this a positive number or a negative number? This is positive, so it's a positive correlation. And it's above 0.7, so we're going to say it's strong. Here, real quick, I know the thing is going. This is also positive, but this is 0.22. It's really close to 0, so this is going to be weak. All right, go to the next one for the back.